the best part, in my opinion, about the CO2 units is that it is completely loaded with sensors and measuring points and everything like that. Everything can be remotely controlled. You can make trends of everything. So when there are troubles, you have a few guys in the office that really know what they're doing. They can, from a distance, check what's going on and guide the mechanics through the problems at that point. But yeah, in a basis that is not the starting point that you want to leave at.
Welcome to the Refrigeration Mentor podcast and CO2 Mondays. Super great that you're here again. I want to thank all of you once again for coming each week, hanging out with us, listening, learning, sharing, sending questions and comments. Really appreciate that. That really helps me want to show up every day and every week. And that's what I'm doing. This week, I got a great guest. I actually met at Chilventa, and I'm really excited about this because as you guys all know, I like to bring in manufacturers, technicians, and now I'm bringing in business owners. And what's really cool about this, we're going to have a deep conversation about what they are seeing and what Ronald's seeing in the industry. So Ronald Vandenberg from Govers Koeltechniek. He's the director and co-owner of this the company, and you'll probably correct me on that. And we're going to dive into what Ronald's been seeing for CO2 over the last few years. They work more on the industrial side. Ronald, welcome to CO2 Mondays and Refrigeration Mentor Podcast. How you doing?
Thank you very much, Trevor. Yeah, I'm fine. Thank you very much, and thank you for having me.
Awesome. Why don't we start off, do a little introduction about yourself, the company you're at, and where you're at with CO2.
Yeah, thank you. As you mentioned, we are a refrigeration contractor based in the Netherlands. We have a company of about 25 people right now, and we mainly focus on the semi-industrial to a little bit bigger industrial units. For us, as a relatively small contractor entering the world of CO2, I think about 7 or 8 years ago, it was quite a big step. And yeah, but what we see now, it's I think 80% of the units that we ship right now are CO2 based. So yeah, wow. Definitely a good step from that point.
So let's talk a little bit about your background, because I know I looked you up. You were an engineering background, Bachelor of Science and stuff, and now you're a co-owner and director of this company. How'd that happen?
Yeah, that's quite an interesting story, I believe. 8 years ago, I finished my Bachelor of Mechanical and Electrical Engineering. And from that point, I finished that education on an internship at a company that made emergency generators. So looking at my education and the work I was doing, it was diesel-powered electrical generation. Yeah, a better combination wasn't possible at that moment. So that was very interesting. Did it for about a year. And after a year with my bachelor degree, changing oil every day, yeah, I came to a point to say that maybe this is not the best place for me right now. At that point, my father stepped in, and he is an owner of a refrigeration business. He is in refrigeration, I think, about 30 years right now. Always has worked at Govers Koeltechniek, and 11 years ago, Mr. Govers himself said it's time for my retirement. So he sold his business, and part of that business was the industrial refrigeration part that was my father was director at that point. So he bought that piece of the company. We moved to a different building, and from that point we were with I think 10 employees at that point. And now we are at 25. 7 years ago I entering the workshop, did some reefer repair, just get a little familiar with the refrigeration side, because refrigeration was completely blank for me at that point. Did my F-gas papers so to get my certificates and everything like that. Getting a little bit more into the design, the office work at the beginning. 3 years ago, I did my post-bachelor on refrigeration. Let's say one of the higher educations in Holland you can get for these things. And from that point, going more and more in the footsteps of my father, so designing, selling, and making the best refrigeration unit that we can possibly make with all the funky things we see in the field. And together with the team that we have, it's a great effort to do.
Yeah, no,
Really
I love
enjoying
that.
it.
Yeah, no, that's great, because now your dad did it for a long time, started his own business. Now you're getting involved, trying to figure
Yes.
out what to do, and it sounds like you're enjoying it because you're still in it. You're still doing it.
Yeah, of
Now
course. And
you're part owner.
yeah, and you see many times that the father-son combination is the recipe for trouble. But in our situation, we are quite the same in a positive way. So I really enjoy also working with him. So yeah, it's every day is a pleasure.
That is
Absolutely.
awesome. That is so great to hear. So you guys went from 10 people to now 25. So you've grown quite a bit over the last
Yes, we have
decade, and now you're starting to move into more of the CO2 side, right? Because I'm guessing before that, like I guess 7 years ago, you said you started to see more and more CO2.
Yes.
You guys were mostly working on ammonia, or was it synthetic and ammonia before?
Oh, I think the capacity range that we mainly work on is between 50 and 500 kilowatts. And mainly my dad's a real ammonia guy, so that's quite funny. I'm a little bit more on the CO2 side, and he still does his ammonia thing, so that's quite funny. But for the smaller installations from 50 to 200, 250 kilowatts, that was mainly HFCs. The really big freezing installations were ammonia, but yeah, the 75% was HFCs at that point. The first CO2 unit we placed was 2014. That was very scary at that point.
Yeah,
it was a rack that was built by a wholesaler in the Netherlands, and their support and that was amazing. And unit is still running fine, and everything was okay. But at that point, yeah, it was quite interesting to see that. I personally wasn't involved with that one, but I see the P&ID of that unit, and I see the components used in that unit. Yeah, mainly the pressure ratings on all those components are a little lower than they are right now. So that was we have seen some snow coming by on hot summer days with that installation. Yeah, and I think my first installation was in 2016, I believe. Yeah, and from that point on, it went really fast.
Yeah. So back in 2014, 2016, you probably were these like process plants where they blast freezers. What kind of application were you building these units in?
Yeah, the first one that I was part of was a production facility of vegetarian products, and that was indeed a centralized system with a spiral freezer, with a blast freezer, some cold stores, production room cooling, heat recovery, air conditioning, whole the bunch combined. So yeah, that was a very nice beginning, to say that.
Yeah, well, that's one cool thing about CO2 now, and probably the first time you've seen that. Now I got air conditioning, I got heating, I got cooling, I got freezing, all happening all at once. A lot of people like this is super intimidating, and it is at first because
it was absolutely
it is
scared as hell.
Yeah, and that's fair, and that's good to be honest, because there's people out there right now that are starting to see that for the first time, where you were actually able to see it about 6, 7, 8 years ago, and grew a lot from there. What was your next step? So back then, you guys had, the equipment was not the way it is now, but you did have, some manufacturers out there like Danfoss and a few other manufacturers who have been in the CO2 game for quite a while, who have been really developing their products. And over the years, and that's what we continue to see. I continue to see these manufacturers build better products compared to when you started even 7 or 8 years ago, right?
Yeah.
How has that have been like from the support from the different manufacturers that been working with you?
And we see that the first unit that we did was one of the first bigger units that Advanzor built at that point. So they were at a small factory in Aarhus at that point. One of the main designers right now was there at that moment for the commissioning of that unit. So also for them it was quite interesting, and yeah, it was based on Danfoss controls, and not all the regulations that we needed at that point were already as a basic thing embedded in these controllers. So yeah, we had to pull some tricks to get everything working. And yeah, the surprising is that from a regulation standpoint, there's not many changes in the way that the controllers are working right now. And also 2016 is not that long ago. The biggest change that we see is in the availability of components, valves, solenoid valves. We now have a little bit more difficulty also with piping for bigger systems, and yeah, the hardware component is the place where we have the biggest improvement of all.
Awesome. Awesome. And that's what I'm seeing too. More manufacturers starting to develop and build these products, which is great for the industry, because we do need more CO2 products out there. Let's talk a
Yes.
little bit about the transition. So you guys were doing HFCs, a lot of synthetic refrigerants and ammonia, and there's still ammonia there. But now there's a transition. You had this transition. You got to learn CO2 2014, 2016. How was that going from just always working on synthetic refrigerant equipment, and now you get into CO2, which is a huge animal over synthetics, because we've been doing that all the time, all along.
Yeah, yeah. For me personally, I haven't done very much HFC, of course, because I quite fast started with the CO2 game. But with the HFC systems that we have running, because there are still some left and right, is yeah, the attention to detail when building those systems, also with the mechanics, is just they are way more detailed, and they work way cleaner, because they know the littlest speck of dirt can cause a lot of trouble. So it's something that you know for sure, with compressor breakdowns and everything like that. Another big difference is, of course, the attention to safety. With an HFC system, yeah, you may have some ventilation in the machinery room just because it gets too hot in the summer with an HFC unit. And with CO2 everywhere where we have some equipment that has CO2 in it, needs the detection and ventilation and everything that's needed with that. So yeah, that is a very big difference, and that's also something that the users and the mechanics themselves see, that there's quite a little more danger in working with these refrigerants compared to their chemical counterparts.
Yeah, and I definitely agree with you there. There's awareness you need to have. It is higher pressures, and I've been doing so many trainings, talking with so many technicians, and learning about some of the things that they have done or in the field, because they didn't know, because the training's just not been there. A lot of systems are going out, and they haven't had any training or had time to train. Maybe one or two people at their company been trained, or maybe even 5 or 10 people at their company. But when you have hundreds of technicians or employees, it's difficult to be able to train them all for the amount of new equipment and the way the regulations are changing and the new equipment's coming out. Can you kind of talk about that, what you're seeing there in Holland or in the Netherlands, about the training for going from an HSC system to a CO2, or just CO2 in general?
Yeah, that's a tough one, because the amount of training available from a real training point of a standpoint, there's not that much available. We have the safety trainings, of course, to have the certification to that you are aware of the hazards, and that you can safely work on the systems. But that doesn't compare with a real in-depth technical training, that you know what is happening inside of that unit, and what does that transcritical exactly mean, and what is happening, and also the combination with the heating and the air conditioning, and everything combined, that's not something that I can sign up my mechanics to go 2 years to that school and everything about CO2 refrigeration. That just isn't there. The training that we get is from the equipment manufacturers, like an Advanzor. But that's also specified on their units and not mainly focused on the basis of CO2 itself. So the best part, in my opinion, about the CO2 units is that it is completely loaded with sensors and measuring points and everything like that. Everything can be remotely controlled. You can make trends of everything. So when there are troubles, you have a few guys in the office that really know what they're doing. They can, from a distance, check what's going on and guide the mechanics through the problems at that point. But yeah, in the basis, that is not the starting point that you want to leave at.
Yeah. So you said a minute ago, like a 2-year program. Is that something that you would, as a business owner or contractor, would that be something you would be interested in, to have your technicians go into a program? Maybe it's a night course, or a couple of weeks a year, or a couple of months a year, going into a course to learn about these technologies?
Absolutely, absolutely. We see that the trainings that they can get right now, they are a little bit more plain. They even calculate with R22. Then you know what time it is. The point is, and also one of my colleagues that is responsible for the training of the guys at our company, also had a discussion with the institute that gave those lessons. Like, why aren't we learning CO2? Because 80% of the units that we do is CO2. Yeah, that answer was very clear. 70% of the people that are in our classes are doing HVAC, and most of them are doing residential HVAC and heat pumps. So yeah, it's very nice that you want to do CO2, but yeah, the most part of the people are never going to work with CO2. Yeah, that's then the end of the conversation.
And that's exactly what I've been seeing everywhere globally. Like, even here in Canada, we have some great institutions and great trade schools and colleges. But at the end of the day, 70% of the people are in the AC side or HVAC. And for me, I'm really thinking that we need to have specialized programs. And I've been noticing this for quite a few years now. And for commercial refrigeration here in Canada anyway, at least we got a better playing field. But when we look at the ammonia, there is no, in our trades, we got 5-year apprenticeship programs. There is no real ammonia training. That, depending on the school you go to, they may have a teacher that did ammonia before. And don't get me wrong, there are some schools that'll teach more than others. But the main curriculum is focused around more on the HVAC side, I've seen myself. And once again, it all depends on the school that the people go to here. And in the States, it's even more on the HVAC and AC side, and like you said, the residential side. So it's me, I'm trying to figure out, how do we get more commercial refrigeration into the schools, into the curriculum. And maybe it's something separate. Maybe it's a total separate program for the ammonia side, for the CO2 side. But
as I mentioned, the safety programs are already in place for ammonia, for CO2, and the hydrocarbons. But as I said, that's only the safety side, and that's I think the main training is 3 days, and then the backup training, the refresh training, is 2 days, something like that. Correct me if I'm wrong, but something in that order. And I think the point with ammonia training would be, the lucky thing with ammonia is it kind of behaves the same like an HFC, because everything is still subcritical. I know it's toxic and the volumes are way bigger, but the basis of condensing and evaporating is still the same. And yeah, then when you open the page for a CO2 system, yeah, then suddenly some strange things are happening. And yeah, that is something that you have to learn in company. You have to learn by trial and error. You see that the bigger installers in Holland, all start with in-company training, so internal academies to train their own technicians. For the same reason, they cannot go anywhere else.
Yeah.
So
So
then
the
you
same
must do it
things
on
that are
yourself.
so the same things going on there are going on here. So it's not, this is a global thing. It's not just a select country thing. So, and I've been seeing that and talking to lots of people in different continents and different countries. So,
You have
okay,
work to do.
so 2014 was the first one that you guys did. 2016 is the first one you were involved in. Now,
Yes.
over the last 6 years, how did that evolve for you? Because you're saying 80% of your equipment now is CO2. Is it still strictly just process plants, but are you doing heating, air conditioning, cooling on all of them now? And what has that journey been like over the last 6-7 years?
Yeah, we see that the capacities are growing both ways. So last week we installed our first CO2 condensing unit of, I think it's 4.5 kilowatts. We are about, I think a year ago, we made a cooling system for a bakery, which was at a combined capacity of about 700 kilowatts or something like that. So we see it growing in two directions, where with the bigger units, we see the heat recovery is becoming more and more important, of course. So for the centralized setups, we see from 100 kilowatts to 800 kilowatts and everywhere in between. It's quite versatile, so it doesn't matter really how big it is. If it's below 1 megawatt, it's very easy to build it in CO2. Everything bigger than I think it's not that fitting anymore. But we also see CO2 more and more in pumped systems. So I think about 4 years ago, we made our first pumped CO2 system, and then in the configuration that the CO2 was the transport fluid, so it was the evaporative brine, with a propane direct expansion unit on top of it in cascade to provide the cold at that point. It was used for the long-term storage of fruit, so apples and pears. And also in these conditions, a pumped CO2 system is with looking at the way that fruit is stored and the quality of the fruit which comes out of that cell after a year, and it's phenomenal. I haven't seen any better alternative for a pumped CO2 system for these situations. So 4 years ago, we didn't dare to make it directly transcritical, so that's why we made the combination with the propane on top. We did that 3 times, and yeah, it's working fine. But yeah, you still have that propane on top, and yeah, I know it cools very well. It behaves really like the refrigerants that you're used to, but still, if you have to change the check valve somewhere and you have to put your torch on it, and you know it's a propane system, yeah, it's not the best feeling in the world to work on that. So that's why as soon as we were confident enough to make the switch to fully transcritical pump systems, we did that. So we built 2 right now. Yeah, and it's running like a dream. So yeah, I'm very happy with that.
So let's talk about that a little bit. So you're saying they're pump systems. So some people call that secondary systems or fluid systems. So it's actually, you have CO2 going out, and you would have solenoids, I'm assuming, at the inlet and outlet. So you're using solenoids to control, and it's just a fluid going out, and you'll have big vessel in there. So all that saturated refrigerant or wet gas would be coming back, saturated gas coming back. Were you also doing with this system? So that was propane on the top. So it's a regular DX system on the top with, you have a plate heat exchanger in between, which would be a condenser evaporator. And then you'd have your secondary pump system. And then you're saying now you have a transcritical pump system. So you're using transcritical on the top, but you're pumping the fluid. You're not doing DX. Is that correct? Or are you doing DX?
Yeah, no, we are pumping at that point.
Okay.
Yeah.
Cool. So this is even new to me. I've seen it before. I haven't talked to many people who have these installations. So now you got a transcritical on your primary side, But on the secondary side, you're pumping out the CO2, and you're doing this because it's giving you better quality refrigerant. It's keeping the temperature better for you,
Yeah, it's
for your product.
mainly compared to age of the Freon systems or even ammonia systems for these types of installations. We see that with CO2 to get the optimal amount of cooling hours, the optimal amount of dehydration of the product, we can do that with higher evaporating temperatures, which means we can run. We have less frost buildup. We can use a little less electricity to keep everything running. Yeah, it's a very direct and very aggressive refrigerant in the pumped state. Yeah, and it's because it's pumped, it's stable as a rock. So yeah.
And this is
nothing gonna happen there.
This is what's so cool about learning about CO2 and the different technologies, because I worked on a lot of glycol systems where you're pumping out the fluid, but that's just sensible heat. You're only getting the sensible heat transfer there, where with CO2 now you're getting both sensible and latent heat transfer, which is huge. And and this is what's cool about the way it evolves. You know, you started with the transcritical, but now you're moving to a pumps system, and that's really cool how you can find the proper solution for your customer, because at the end of the day you're working towards getting the right solution for your customer on that specific application, because maybe not every application that's going to work perfectly, but for your specific ones it sounds like it is.
Yeah, and we see that with the transcritical pump systems, is that because you have flooded evaporators, you have high capacity on your evaporators, with cooling tunnels and freezing tunnels and all those intense applications, we just see better results than with direct expansion.
Yeah, no, I love that. I love that. And this is going to help lots of other people out, because I know I'm working with engineering firms, other contractors who's asking me, like, not really sure what solution I should go with. So thank you for sharing that.
Yeah,
thank you for sharing that.
When the only thing with working with pump systems is you have to make sure that you select the right pump, because if you don't select the right pump, you have a very bad summer.
Yeah, you have a very bad time, that's for sure. But it's good to understand this stuff, and like you said, that now that you're using the pump system, that you can have a higher suction, you're doing less of a compression ratio, or you're doing less work, like you said, which is very important. At the end of the day, your customers are now, energy costs are going up. How do we squeeze out a little bit of more savings for the customer and get a top quality product out the door, right? So
yes,
that's really good to see. So how is so now you get into the pump systems over the last 4 years. How has these transitions been for your team? So the technicians out there, the project managers, the salespeople, the engineers, like, how has the transition been going for them? What you've seen as the business owner?
Yeah, I see that the guys that are involved with the commissioning and the build-up of these systems, because they start from the beginning. They learn how the system works. They learn how it's built up. They know the components. They had them all in their hands, and they had the training from the manufacturer at some point. So step by step, they get the confidence that we can work on this system, because they know how it's built. They know the components. And that combined with the more technical background of the guys at the office, gives them enough confidence to work safely and on these systems. For the service department, we see that learning curve was a little steeper, and there was we have we get a call at midnight on our service line. We have a CO2 alarm. That's always a fun one. We have a CO2 alarm. What do we need to do? If you are in bad luck, they maybe call the fire department, and then you have a very interesting discussion at that point. But the mechanic who's on call right at that point, who is sent to that call. Yeah, if he is not familiar with that specific place, and he doesn't know what's exactly going on, in the middle of the night, yeah, that's not always the best scenario to have. So at that point, a little more training, not only the safety thing, but also just a basic understanding of some things. Yes, absolutely a welcoming thing in everything that we do.
Yeah, and I think that's gonna continue to evolve. I hear this a lot. I talk to a lot of technicians like Trevor. I work on supermarkets all the time. I work on parallel rack systems all the time. No problem for synthetic refrigerants, but I don't want to take a call for our CO2 stores. You know, I avoid those calls if I can. At the end of the day, it's probably better to learn during the day in the proper work hours and go there and do a maintenance and service to start learning it. Try to embrace it, even though it's uncomfortable. Then getting called 2 o'clock in the morning, and then you're really, stressed out, and it's going to be a tougher to learn in a harder situation where the system's down and not working. And I'm really talking to more and more technicians about, you need to learn the ins and out of the system. Like as the construction guys are building it, they kind of learning the different parts and components, especially the startup guys. And I really believe that more of the service technicians and even the construction guys need to understand that startup, because with the startup guys and when the manufacturers there helping the startup guys start it up, they're looking at every component. They're looking at every transducer. What does this do? What's this filter do? And I think we need to spend more time on learning the specific systems, getting into here's one big tip for everyone who's listening: learn the PIDs, the piping and instrumentation diagram. And it doesn't matter if it's CO2. This could be a heat pump, but when you understand where the gas is going, what it's hitting, what components next, then it's going to really help out. And I think this is what a lot of service techs need to get involved, embrace it a little bit, understand the system as a whole. But goes back to what you said, training. You need a bit more training, and it's hard because they're out putting out fires all the time, they're servicing every day, trying to even fit that in. You got family times, you got vacation, you know what I mean? So trying to fit that in, it really has to be scheduled. Like that, the companies really need to schedule if they have the opportunity to have any training, depending on where you're at.
Yeah, and then the nice thing with the more industrial setups is that most of the times you have the P&ID hanging on the wall in the machinery room. So first thing you do when you enter for a service call, just let it sink in. What's going on? Look at the system. How does it look like? What's it built of? What components, cases, evaporators, or equipment is attached to it? And from the point where you can understand what's going on and how is it built up, that's the basis to face the issue at that point. But first you have to know what you're dealing with.
Yeah, I totally agree with that. And this is why we're doing this stuff, Ronald. This is why we're having these conversations.
Absolutely.
We do have a question for the pump systems. Were they for medium temp or low temp, or both?
The units that we have right now are only for medium temp.
Only for medium temp? Awesome. Yep. Okay. Good to know. Excellent. So we know for sure training's super important. We need to do more on that. We know that you're moving more into the CO2 transcritical side. You do have some secondary systems with propane. I guess, how was that adjustment going into propane? Because that's a totally different animal even compared to CO2. Was that your first system when you did the pump system with propane on the top side, primary side, and CO2 on the low end? Or
yeah, it was.
Side?
It was, and till this day, for the fruit storage, it's the best unit that we have running. So for now, looking at the result of the storage of the product itself, but that was we started that project, just with the feeling that yes, we can do this, and eventually, of course, we could do it. But yeah, we paid some learning money on that one.
Yeah, and that's how you learn and grow. What is the thing that you just said that it's like one of your best units? How, like, is it's holding temperature of the product the best? It's the best efficiency, like because there's a lot of different factors. It's easiest to service and maintain. What do you mean by that?
No, it's from the standpoint of the farmer. So the quality of the storage of pairs is measured in the amount of cooling hours that the unit makes and the amount of dehydration that the fruit has during a week or during a fixed period. And we see that with this unit, compared with, let's say, 15 or 20 other units that we are running in the field, this one is doing really the best every year, year in, year out. And even the trader of the fruit says that this is one of the best storage results that they have at the moment there. So
that is super awesome.
We're very proud on that one. Absolutely.
That is awesome. So, and it's something that you can, build off of as well, right? Because now that farmer understands, wow, this is a good unit. What on the primary side, how much propane or R290 were you using on that? Like, do you have an idea of how many pounds or kilograms you'd be using?
Yeah, that unit was filled with, I think, 22 kilograms of propane. So it's a very small system. We use the condenser, the bottom part of the condenser part, as a liquid receiver. So we don't have a separate liquid receiver in the unit, just to keep the volume as low as possible. And yeah, there's just enough propane to keep it running. But yeah, also the Dutch legislation with the usage of propane is not that easy. So we try to keep it as low as possible, and that's also the reason that for these applications we try to move away from propane, because at that point it was a very nice unit. It's the cooling results are amazing, but I believe that the direct transcritical pumped units can deliver the same results without the flammability issues.
Oh, and that's really good to know and understand, because that flammability brings a whole new animal into the mix, and if we can reduce that and then get the understanding of the higher pressures, I think there's going to be there's going to make an ease for the technicians and the service providers and the professionals working on these equipment, because at the end of the day, putting a torch on something that has R290 and is different than putting a torch on with CO2 or synthetics as well. You still have to be safe either way.
No, of course. The point is we do HFC, we do ammonia, we do CO2 transcritical, we do the hydrocarbons. So as a mechanic, it's quite a challenge to keep up with everything. So yeah, that's when we had the possibility to move away a little bit more from propane. It's of course the newer water chillers that you place are all R290, of course. But yeah, for the bigger installations, just try to keep it with CO2, and we're all happy.
Yeah, and that's one of the big things that I try to teach and educate different professionals around the world. It's like, refrigeration is big. So take your time, try not to learn it overnight, because you're not going to. I've been investing 18, 19 years into it now, and every day I feel like there's something new I'm learning, or I feel like I'm at the beginning of this new journey of refrigeration. So for all of you that are servicing equipment, maintaining equipment, there is a lot to learn, but just take your time, want to learn it, invest in yourself. That's the biggest thing, because I see a lot of technicians who just go do their day job, which is great, and they're crushing it. They're going in, doing the service calls, doing the maintenance, but that's not enough if you want to learn what's going on in the refrigeration industry. It's changing so fast.
No, and very simple. When you drive home, just listen to the Refrigeration Mentor podcast, and you will be up to date as soon as possible.
Yeah, exactly. Because there's just so much. Thank you for that. There's just so much to learn, and it can be overwhelming. But the thing is just learn a little bit. Reach out to different manufacturers. They want to help. I talk to so many manufacturers. They want to help, specifically under equipment. So if you're working on that equipment, get some advice from them. Reach out to wholesalers or different experts in the field. There's lots of people on social media that you can reach out to, and it's important to, as a company, if you're a business owner like yourself, I'm sure these are resources that you talk to your teams about and your team leads. Like, how do we encourage them to do a little bit more education, right? Because at the end of the day, when you understand what you're working on to the best of your ability, your confidence level goes up. What I see right now, a lot of people are really good working on, say, synthetics or HFCs, their confidence level is really high. But now when we get into CO2, their confidence level is really low because it's the unknown, it's new, and we really need to invest our time in that stuff.
Yeah, and when those guys began, let's say 20 years ago, they also needed to build that confidence that they have right now with the systems that they know. So it's just you just have to start. Don't be afraid. Just dive in, and it's not like it's not magical. It's technical, but you have to grasp it at one point. So
Yeah, I'd love it. So, what advice would you give to other industrial contractors, starting to get involved with CO2 now, because you already did the process, you did the jump, you went from the synthetics and ammonias to the CO2, but there's a lot of contractors out there that are where you were in 2014. What advice would you give those contractors out there?
Yeah, first of all, yeah, as I mentioned, just don't be afraid and just put yourself to it and do the research. If there are any trainings nearby, try to do them. There's a lot of information available on the internet. You have a lot of information about it, about all the stuff. But yeah, and also be aware that you're gonna have struggles. Just made a short list of all the main struggles that I can remember from the last years that we did. Yeah, that you have to pay some learning money to get a hold of it. And yeah, it was also back in school. You have to make mistakes to learn something, and also don't be afraid to make mistakes. Work safely, and at that point, just get your confidence level up. Get your just make sure you make the hours, put in the work, and yeah, the rest will follow.
Yeah, no, I totally agree with you there. Work safe, but put it in. You're gonna, like you said, you're gonna make mistakes because all the people that are doing been 20 years, 15 years, they made tons of mistakes in the HFC and the regular stuff, the regular refrigerant, and it's important to, yeah, you make a mistake, learn from that mistake, because I made tons of them.
Mm-hmm.
Broken compressors, broken valves, improperly installation, bad wiring. I did all of it, but I learned from it, right? So I did all of it. So,
yeah.
but you learn from that and you grow.
And also be prepared to see some strange things, because one of the things that also was a combination with that CO2 detection. We had a bigger, there was also a propane CO2 combination, and that was for vegetable storage. And yeah, we work with CO2 in that cold store. So of course we fitted it with CO2 detection. And every weekend on Sunday afternoon, every week, we had a CO2 alarm. Yeah, you check your loggings, and you see that every night when the door of that cold room closes, it increases a bit, the CO2 level, and then it opens again, so it drops down. But during the weekends, the door stays closed. Yeah, nobody was looking at that trend, of course. But yeah, then you're gonna think, all right, what's happening here? And of course, the vegetables that are inside that cooling cell create that CO2, which triggers the CO2 alarm. Yeah, that gave us some thoughts to see. Also with those things, how do you deal with that? So that was also quite interesting to see.
That is super interesting, right? So everyone take note of this, because if you're working with that makes so much sense, right? Because it's building more CO2 up in that box or in that room, and those alarms. So that's pretty awesome. That's a great tip.
That's an interesting one.
Do you have any more tips like that? Because I'm sure you.
Yeah, the thing that we see, and that's the difficulty that we have right now actually, is with the bigger capacities, the design of the piping systems. With the smaller units, you can do it with copper K65 and everything, and that's most of the time that's not an issue. When you switch over to stainless steel, and then if you would use the American sizes, so the schedule sizes, you have welded pipe, maybe you have welded fittings and everything like that. Getting your strength calculations right, and make sure that you have to do some non-destructive testing on seams and everything like that. Yeah, that looking at the whole design difficulty of a normal transcritical system, I have more difficulties to getting the piping right than just designing the whole system. So that is something that is at this point, something that's taken a lot of time, a lot of discussion with notified bodies and everything like that, just to get it approved and ready for usage. So piping design, not only that it's working, but that it's safe and it's approved for the pressure ratings. That is something that's very important to keep in mind.
Yeah, no, that's a good one, because I'm learning more. I'm not an expert in the piping design. I'm still learning, but I know the pipes, like you're saying, they're getting bigger and bigger, and so the bigger they get, the less sturdy or the less strong their burst pressure starts to change, and that's what you mean, right? And you're talking about the bigger the pipe gets, the less I guess strength it has. I guess so. You gotta get different schedules, thicker pipe. And that's important. That's something that's going to continue to learn, because I talk with more and more people about it. Because as these systems start to grow, the pipes are going to start to grow. So that's a great tip.
Yeah, and it's not only the straight tubes, it's mainly the T's and the elbows that make the weak points in these installations. So everything needs to be calculated and everything needs to be up to spec and according to the code.
Yeah, no, and that's it. You definitely have to follow what is going on in your local jurisdiction. Doesn't matter where you're at in the world. Follow those codes, follow up with them, because it's even new for some of the regulations and the jurisdictions. They're like, we don't know yet, so be patient, because I got people out there, they don't even know this and that. Well, it's so new to them. They're trying to understand it, so be patient with them if you can as well, because yes, they're making the regulations, they're supposed to be enforcing it, but some of it's new. It's new to everyone, right? So depending on where you're at in the world, they're going to be way ahead with the regulation. They're going to understand that Schedule 80, Schedule 40, stainless steel, K65, whatever it is where it's at, depending on the size. But other places, it's not going to have that information. So sometimes you're going to have to dive in yourself, like you're saying, and try to figure it out on your own.
Yeah, and also don't be afraid to contact your notified body on these things, because they're not only there to approve or reject your installation, they're also there to help you. You are their customer. So when you have questions and if you're not certain about certain things, just ask them, start a discussion on how you should handle these things, because they are the people that are gonna say it's okay or it's not okay. So ask them, how do I need to approach this? They're there to help you.
I love that. It's so important. They are. I love that. Thank you so much for saying that. So is there anything else you want to share or offer the audience?
I think that the main things that we spoke about are covering the main things. A good thing to see, and that was also something that we saw at Chilventa, of course, the amount of products that are coming to market for the higher capacities. That's a good thing to see. You also spoke with Patrick Lardy, of course, from Danfoss, about all the new industrial stuff, the new regulation stuff and everything. It's very exciting to see, and it also helps us as a refrigeration contractor to build better and more compelling installations for our customers. And at the end of the day, that's why we're here for.
Awesome. Yeah, I totally agree with you there. Ronald, how can people get a hold of you, get a hold of your company if they're in the Netherlands or in Holland or want to get in touch? How do they do that?
You can send me a message on LinkedIn, of course. And on the other hand, you can visit our website, goverskoeltechniek.nl. We are based in Gilze, that's the south of the Netherlands. And if they have any questions, I think if they go to you, then it's more than a pleasure to reroute them to us, I think.
Awesome. I want to thank you so much, Ronald, for taking the time to hang out with us, sharing your knowledge and your experience with CO2. And I will see everybody at the next CO2 Monday. Have a good one. Thank you.
Thank you for having me.
Hey, I want to thank you for taking the time to watch this video. I hope you got something out of it, something that you can use in your daily life. If you like this video, hit the thumbs up button, hit the subscribe button, and click the bell button, because when you click the bell button, it will notify you anytime new videos are released. Also, check out the Refrigeration Mentor webpage at refrigerationmentor.com, where I'll have all the different trainings, upcoming events, the different podcasts I've been on, as well as the Refrigeration Mentor podcast. If you want to check that out on Apple, Spotify, Google, any service provider of your choice. Super excited to see you at the next video. Now let's get a conversation going.